In this video, we are going to solve a system by the elimination method. So let's read the problem. A friend says they are thinking of two numbers, but they won't say what they are. He tells you the sum of the numbers is 163 and that their difference is 33. What are the numbers? Pause the video at this time and see if you can set up the two equations that will form this system. When I am solving a system, especially when I'm looking at a word problem, I want to pick out the key words. So the key words for this problem would be sum and difference. So the way I set up the problem was to take x plus y, add to get 163, and then difference is to subtract, so I took x minus y, subtract to get 33. So the key to this problem now is this is set up and ready to go. I like how my x's are lined up and my y's are lined up. You want that to happen when you're trying to use the elimination method. The elimination method is exactly what it sounds like. You are trying to eliminate a pair of variables. So I want to get rid of, in this case, the y's. It could be either way, x's or y's, but it looks like this one's ready to go. A positive 1y and a negative 1y would cancel each other out. That would equal 0y. I tell my students to draw a line under, see if things will cancel. If not, you have to do something to them, but this time they do, and then start working the problem. So add down. X plus x is 2x. 163 plus 33 is 196. Divide 196 by 2, and you get x equals 98. Now it's time to plug in your x value to one of the x's in either one of these equations. I'll just put it into the top one. It doesn't matter. You could do it in either one. So plug in 98 to the top equation. You have 98 plus y equals 163. You're going to want to subtract 98 from the other side to have y by itself, and your final answer is y equals 65. A lot of times when you're solving a system, you want to write the answer as a set of ordered pairs. So your final answer would be 98 and 65. So there are two numbers. If I add 98 and 65, it would give me 163. So you could check it real quick. If I subtract 98 minus 65, it would give me 33. So you always want to check your solution to make sure you're on the right track. In the next problem, I'd like to show you how to solve a system where it's not ready to go. Thank goodness the x's and the y's are lined up, but nothing will cancel right at the moment. So pause the video and see if you can do something to one of the equations to make a set of variables cancel. So what I would probably do is multiply this equation by a 2. When I multiply it by 2, it's going to cause my y to become a 4y. So 2 times 3x is 6x, 2 times 2y is 4y, and 2 times negative 6 is negative 12. So I've just turned this 3x plus 2y equals negative 6 into this equivalent equation. I start working the problem by rewriting the original problem. So I rewrote the 8x minus 4y equals negative 16. And I took my new equation and put it underneath. So we're ready to go again. Draw the line and start combining things in their columns. And we notice that a negative 4y and a positive 4y definitely will cancel. And I'm going to start adding my other pieces. So 8x and 6x gives me 14x. Negative 16 and negative 12 is a negative 28. Continue, divide negative 28 by 14, and the answer is negative 2. It's time to plug negative 2 into either equation. I'm going to choose the second one. It seems a little easier. So I'm going to plug in a negative 2 in for the x and start working the problem. So 3 times negative 2 is a negative 6. Continue writing the rest of the problem. I need to move this -6 over. So when I move it from one side to the other, it changes signs, or think of it as adding 6 to get rid of it on this side. And whatever you do to one side, you have to do to the other. So you end up changing this -6 with this one when it moves over to a 0. And then 0 divided by 2 is 0. So again, write your final answer as an ordered pair. And it definitely does not hurt to go plug this x and this y into both equations and see if it works out for you.